Hello everyone, a very good evening all of you and a very warm welcome to you all to this wonderful formula memory test session for fluid mechanics part 2. Please guys do join me fast, and those who are here please do respond through the comment section if my audio and visual quality are fine. क्या आप मुझे सुन पा रहे हैं, देख पा रहे हैं properly? If you face any technical issue, if you are facing any technical issue, please do let me know beforehand so that we can rectify it and you get the video without any disturbance. Hi Sri Ram, no one, welcome guys, namaskar everyone, adab, shubh sandhya, good evening, sat sri akal, assalamu alaikum, vanakkam. Please get yourself settled down, sit back, relax and enjoy the beauty, provided you should participate yourself in the session. So quickly मैं अपना introduction दे देता हूँ for those who are seeing me for the very first time. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination which is conducted by UPSC. I am having industry experience of more than 4 years, out of which 2 years of experience is in Steel Authority of India Limited and rest of 2 years of experience is in a private consulting firm. Last 10 plus years, from the last 11 years, I have been into teaching, guiding the students who are preparing for various competitive examinations like GATE, ESE and PSU. Are you from Nepal? Surat? Is it? Oh my God. Are you appearing for GATE? So this is my telegram to join. Already more than 1500 students are part of my telegram channel, and if you join such a large group who are having like mindset, it will definitely help you. It will motivate you to crack the examination. It will help you to discuss your doubts, discuss your queries, and the important notification will also be provided to you through my telegram channel. So if you are not part of my telegram channel yet, please do join it. The link is already mentioned on the screen. All right, and day after tomorrow, that is on Sunday, there will be a national level scholarship test for GATE aspirants. And if you appear in the scholarship test and if your performance is good, based on your performance, you can get our paid courses at a discounted prices, right? So you just have to register yourself. Registration is completely free. The test will be conducted between 9 AM to 9 PM. You can select any slot, appear for the test and get benefited through the scholarship on our paid courses. The link is already there in the description box. So let us start without wasting your time. Let us start with question number 1. The question is from the kinematics, the general form of expression for the continuous equation, continuity equation. Continuous equation means equation of continuity in a Cartesian coordinate system for the incompressible or compressible flow is. Which is the correct answer? Yes. All are form of continuity equation. This is for incompressible only. The equation number 1 is for incompressible only. Equation number 2 is for steady flow. Equation number 3 is for unsteady and compressible plus compressible. It is incompressible. The flow can be steady or unsteady. And the second equation is for steady flow. The flow is compressible, steady and compressible. The third is unsteady plus compressible, and the fourth equation is nothing. So the equation which can be applicable to incompressible or compressible flow, that is the general equation. This is the general equation for continuity equation. This is the general equation, or we can write it as del rho by del T plus del dot rho into V is equal to 0. This is another way of writing this continuity equation. Yes, C is the correct answer. Notification नहीं आ रहा, किस चीज का notification? Hi Maniket, welcome. Prantal, yes, option C is the correct answer. The more appropriate answer is option C. Let us move to the next one quickly. It is the formula revision only. What is the answer? That irrotational, for the flow to be irrotational. Bataiye quickly. I want everyone to respond. Quick response is highly appreciated because we have so many questions. More than 50 questions are there. अच्छा, notification हमने on नहीं किया होगा. Hi Saket, Sriram, what is the answer? Angular velocity omega z is equal to half of del v by del x minus del u by del y. That is angular velocity about z axis. If we want irrotational flow, so omega z should be 0, and for omega z to be 0, del v by del x should be equal to del u by del y, isn't it? That is the condition for irrotational flow. Del u by del v by del x is equal to del u by d. तो गलत है. C is the correct answer. It is C. It will be C which is correct, isn't it? Option C. The next one from the stream function. Regarding the stream function, everyone, well done. Rohit, Sriram, Deepak, good. Vinod, Maniket, well done guys. What about the next one? Capture live with me. Good evening. Welcome to the session. Stream function, there are two functions. One is velocity potential function. Minus del phi by del x is equal to u. Minus del phi by del y is equal to v. And minus del phi by del z is equal to w. The flow takes place in the direction of decreasing potential. And about the stream function, del psi by del y is equal to u. And minus of del psi by del x is equal to v. Flow takes place in the direction of to the left of the flow direction, the stream function decreases. Or we can also write it as, both are correct. Either we write this way or we could have written like this. Minus of del psi by del y is equal to u and plus of del psi by del x is equal to v. Both are correct. Both the expressions are correct. So what is u? Del psi by del y. A is not correct. Del psi by del y. B, both cannot be negative. One should be negative, another should be positive. One should be positive, another should be negative. So B cannot be correct. What about C? C looks fine, isn't it? C is looking correct. C is correct. Yes. Well done. C is the correct answer. And from here we can find out, we can write the Cauchy-Riemann equation. Do you know about Cauchy-Riemann equation? Cauchy-Riemann equation, u is equal to minus del phi by del x is equal to del psi by del y. So from here this is called as Cauchy-Riemann equation 1. V is equal to minus del phi by del y is equal to minus of del psi by del x. This is another Cauchy-Riemann equation. The relation between phi and psi represents the Cauchy-Riemann equations. The next one, acceleration. The convective acceleration of the fluid in x direction is given by which expression? The convective acceleration. बताइए, what is the correct answer? There are two types of acceleration. Convective is also called as advective. Why convective or advective? Acceleration is developed due to change in velocity with space. Due to change in velocity with space, there is a convective acceleration or advective. There are two types of acceleration. Local acceleration, that is del v by del t, that is due to change in velocity with time. With time. So the convective acceleration in x direction. So ax will be given by this expression. This is ax. Option A. अच्छा, सॉरी, ए तो गलत हो गया. करेक्ट. A is not correct. The correct answer is D. Yes, this is AX. Differentiation के अंदर U आएगा. It will be U in the differentiation. AX convective. AX convective. So the total acceleration actually is del V by del T plus V dot del into V. ये लोकल है, ये कन्वेक्टिव है, and this is the total acceleration. Total acceleration is sum of local and convective, where V is equal to U I cap plus V j cap plus W k cap, and del operator is equal to del by del X I cap plus J cap del by del Y plus K cap del by del Z. V dot del क्या होगा? V dot del is not equal to del dot V. V dot del is not equal to del dot V. What is V dot del? V dot del is U into V dot del is U into del by del X plus V into del by del Y plus W into del by del Z. ये होता है V dot del. So this is the expression for acceleration. And what is del dot V? Del dot V होगा del U by del X plus del V by del Y plus del W by del Z. There is a difference between del dot V and V dot del. So this is the expression for acceleration, right? The next one, question number कुछ नहीं है. The next question, everyone, अगले क्वेश्चन का जवाब दीजिए. For flow to be possible, velocity potential function satisfies Laplace equation. Velocity potential function satisfies Laplace equation. What is the Laplace equation? Del square phi is equal to 0. And for irrotational flow, stream function satisfies the Laplace equation. For irrotational flow, the stream function satisfies the Laplace equation. So del square psi is equal to 0. What is del square? Del square is equal to del dot del. And what is del dot del? That is del square by del X square plus del square by del Y square plus del square by del Z square. So both must be equal to 0. जब phi Laplace equation को satisfy करेगा तभी the flow is possible. The incompressible flow will be possible only when phi satisfies the Laplace equation. Are you getting it? And for the flow to be irrotational, the stream function must satisfy the Laplace equation. Answer A. A will be correct. It will be A. For the flow to be irrotational, isn't it? The next question, the next one, free vortex and forced vortex. Free and forced vortex. बताइए. For free as well as forced vortex. For free vortex, rate of change of angular momentum is equal to 0, torque is equal to 0. For free vortex, torque is equal to 0, so V into R is equal to constant. That is for free vortex. For forced vortex, the tangential velocity is equal to R into omega. So we can say V is equal to C into R. For free vortex, V is inversely proportional to R, tangential velocity. For forced vortex, V is directly proportional to R. So V into R is constant for free vortex and V is equal to C into R is equal to for force contact. ये इक्वल टू है, ये इक्वल टू बीच में साइन है. C is the answer. Option C is the correct answer. The next one, the equation gz plus v square by 2 plus p by rho is equal to constant along the streamline. Along the streamline holds true for. This is what? This is the form of Bernoulli equation. This is Bernoulli equation. This is valid for. This equation will be valid for. The flow must be non-viscous. Non-viscous. What does that mean? Non-viscous means frictionless. The flow must be steady. The flow must be incompressible. It means ideal flow. When the flow is non-viscous, steady and incompressible, that is called as ideal flow. So this equation is valid for ideal flow. Steady, frictionless and incompressible. Steady, frictionless and incompressible. C will be the answer. C will be the correct answer. What about the next one? P plus rho gz plus rho v square by 2, commonly used to express Bernoulli equation, has the unit of. बर्नौली इक्वेशन को लिखने के 3 तरीके हैं. What is the answer to this one? There are 3 ways of writing the Bernoulli equation. P plus rho gz plus rho v square by 2 is equal to constant. Pressure into volume is energy. So it is energy per unit volume. Isn't it energy per unit volume? And if we divide by rho, then it will be gz plus v square by 2 is equal to constant. So it is energy per unit mass. And if we divide by g also, rho g, it will become z plus v square by 2g is equal to constant. Now it will become energy per unit weight. Then it will become energy per unit weight. These are the 3 ways of writing the Bernoulli equation. So this form is energy per unit volume. C will be the answer. The next one, which of the following pairs are correctly matched? Next question, which of the following pairs are correctly matched? Head, sum of datum head and pressure head. अगर head की बात करें, P by rho g plus z plus v square by 2g is equal to constant. The constant is total energy head. Each and every terms in terms of flowing fluid head. Each and every terms is in term of flowing fluid head. This is called as static pressure head. The first term is static pressure head. It can be taken as absolute or gauge. It can either be taken as absolute or gauge. The second term is called as datum head, or we can call it as elevation head, or we can call it as potential energy head. The third term is kinetic energy head, or we can call it as dynamic pressure head, or we can call it as velocity head. Now, if we add these two, static pressure head plus datum head, that is called as piezometric. This is known as piezometric pressure head. And if you join these, this plus this, they are known as stagnation pressure head. This is called as total pressure head. We can call it as total pressure head. So stagnation is what? Stagnation is equal to static plus dynamic. Stagnation is static plus dynamic. Now try to check the options. The options are, अब बताइए इनमें से कौन सा करेक्ट है? Piezometric head is the static plus datum pressure head, means static pressure head. Piezometric head is static plus datum head. One is correct. What is dynamic head? Dynamic head is the velocity head. It is not sum of datum head and velocity head. Dynamic head is simply the velocity head. Stagnation head is sum of static head plus velocity head. Stagnation is static plus dynamic. That is also correct. Total head is sum of piezometric head plus dynamic head. That is also correct. 134. 134 B is the correct answer. Yes. Well done, guys. Sriram, Maniket, good. Mohit, Vinod. I want everyone to keep responding. What about the next question? The discharge is given by area into velocity. For losses in discharge, we define the coefficient of discharge. For loss in area due to sudden contraction, we define coefficient of contraction. Due to sudden contraction, we define coefficient of contraction. And if there is a loss in velocity, then we define CV. That is the relation between these three coefficients. CD is equal to CC into CV. Q is equal to A into V. C is the answer. Next. Yes, Saket, Bhaskar, good. Vinod, well done. Everyone keep responding. What is the difference of pressure head? So, if we attach a manometer, if P1 is greater than P2, then the manometric deflection will be like this. This is specific gravity of manometric fluid, and manometric fluid is mercury, and the flowing fluid is oil. So the pressure head P1 minus P2 by rho g. How to denote P1 minus P2 by rho g? What we will get? We will get that is equal to H is equal to X into Sg by S of oil minus 1. That is the piezometric, that is the pressure head difference in terms of oil. This is in terms of flowing fluid head. In terms of flowing fluid. X is the manometric reading, Sg and So are the specific gravity of mercury and oil. What is the answer? D. D is the answer. What about next? The next one. Prandtl's pitot tube was used to measure the velocity of a fluid of a specific gravity S1. Here the point is 1, here the point is 2. V2 is equal to 0, isn't it? And the fluid is S1 and the manometric fluid is S2. So if we apply the Bernoulli equation, so P1 by rho g plus V square by 2g is equal to P2 by rho g. So V is equal to, or V square by 2g is equal to P2 minus P1 by rho g. And what is P2 minus P1 by rho g? That is equal to, if the manometric fluid deflection is H, again S2 by S1 minus 1. So we can find out V under root 2g. From here we can find out the velocity V. What is the correct answer? It will not be A, it will be B. It will be B. B is the right answer. Right? B will be the correct answer. Now let us move to the real flow. What we discussed so far is the kinematics, the questions from the kinematics, and as well as we have discussed the question from the Bernoulli equation. Now let us move to the next one. The transition from laminar to turbulent flow does not depend on, look, it is a Reynolds number, that is rho Vd by mu. It depends on density, yes, it depends on density. It depends on the diameter, yes, it depends on the velocity. It does not depend on the length. It is not a function of length of the pipe. And for Reynolds number to be less than 2000, the flow in the pipe is laminar. For Reynolds number greater than 4000, the flow will become turbulent. It does not depend on the length. So Reynolds number can also be written as V into D by kinematic viscosity. That is how we can calculate the Reynolds number, where kinematic viscosity is equal to dynamic viscosity per unit density. The unit of kinematic viscosity, yesterday we discussed, the unit of kinematic viscosity is meter square per second. Now the next question. Volumetric flow rate. What is the answer to the next one? For fully developed laminar flow through a pipe, so we can say average velocity is given by 1 by 8 mu minus dp by dz or dx into r square, and discharge is equal to average velocity into pi r square. So if you put the value of average velocity, then discharge will be equal to pi by 8 mu minus dp by dx into r to the power 4. Pi by 8 mu minus dp by dz into r to the power 4. Option A will be the correct answer. And in terms of diameter, what it will be? In terms of diameter, what it will be? वहां r था, यहाँ पे diameter है. Pi by q is equal to pi by 8 mu minus dp by dx into r to the power 4. D by 2 to the power 4. How much it will become? So pi by 8 into 16 mu into minus dp by dx into d to the power 4. कितना आएगा? अरे क्या कर रहे हैं मनिकेत? Isn't it option A? Isn't it option A? 128 आएगा ना, 256 कैसे आ रहा है? ऑप्शन ए. इट विल बी ऑप्शन ए. फॉर लेमिनार फ्लो इन पाइप, थोड़े फॉर्मूले में लिख देता हूं. इन पाइप U is given by U maximum into 1 minus small r square by capital R square, where U maximum is equal to 1 by 4 mu minus dp by dx into r square. This is one formula. Second formula is average velocity is half of maximum velocity. Average velocity is half. So it will become 1 by 8 mu minus dp by dx into r square. Third is discharge, that is average velocity into pi r square. So that will become pi by 8 mu minus dp by dx into r to the power 4. Fourth one is tau, that is minus mu into du by dr, that is equal to 2 mu u maximum r by capital R square, or we can write it as minus dp by dx into r by 2, that is shear stress. And at r is equal to capital R, tau will become maximum, that is tau naught. These are some of the formula. The next formula can be written as F is equal to 4F dash, that is 8 tau naught by rho v square, or we can write it as 64 by Reynolds number. These are some of the important formula for laminar flow in pipe. When the Reynolds number is less than 2000, when the Reynolds number is less than 2000. The next question. In a steady flow of an oil in a pipe in the fully developed laminar region, the shear stress is, how the shear stress varies at any section. At r is equal to 0, shear stress will be 0. At r is equal to 0 because tau is given by minus dp by dx into r by 2, or 2 mu u maximum r by capital R square. So at r is equal to 0, tau is equal to 0. and the variation of shear stress is like this. This is tau naught at R is equal to capital R. At the wall of the pipe, shear stress is maximum. Constant across the pipe? No, it is not constant. It is maximum at the center? No, it is 0 at the center. It's 0 at the boundary? No, it is 0 at the center. It is 0 at the center and increases linearly towards the pipe wall. D is the correct answer. Tau is a function of R that is linear. The variation of shear stress is linear in case of laminar flow through pipe. What about the next one? The next question. The frictional head loss through a straight pipe can be expressed as, this is the frictional head loss, this is called as Darcy-Weisbach equation. HL is calculated as FLV square by 2GD, or we can write it as FLQ square upon 12.1 D to the power 5. This is called as Darcy-Weisbach equation. This is Darcy-Weisbach equation, which is valid for laminar as well as turbulent. This equation is valid for laminar as well as turbulent flow. Laminar plus turbulent flow. So, if the flow is laminar, then F is given by 64 by Reynolds number. It will be given by 64 by RE. Option C. C will be the right answer. Next one. Maximum to average velocity in laminar flow through a pipe, U maximum by V average is equal to 2 for laminar flow. And average velocity by maximum velocity will be 1 by 2. Do not commit this mistake. Maximum velocity is twice of average velocity. Average velocity is 1 by 8 mu minus dp by dx into r square, and maximum velocity is 1 by 4 mu minus dp by dx into r square. These are the expression of average and maximum velocity. C is the correct answer. Now for the parallel plates. For laminar flow between parallel plates separated by a distance h, the head loss varies. ये बताइए. What is the answer to this one? What about this question? For parallel plates, if it is having laminar flow, then the expressions are U is equal to 1 by 2 mu minus dp by dx into hy minus y square. That is the expression. Then tau is equal to mu into du by dy. That is equal to 1 by 2 minus dp by dx into h minus 2y. Q b upon 12 mu minus dp by dx into h cube. And what is that? Is average velocity. Average velocity is 1 upon 12 mu minus dp by dx into h square. Maximum velocity, that is 1 upon 8 mu minus dp by dx into h square. So the ratio of maximum velocity to average velocity is equal to 3 by 2, that is 1.5. So the question is, or delta PL, we can write delta PL is equal to 12 mu V average L by H square. That is the relation. Delta PL is piezometric pressure drop. And we can say HL is equal to loss is equal to delta PL by rho G. So it will be 1 upon rho G, then 12 mu V average L by H square. How the loss will be related with H? So HL is inversely proportional to H square. It is inversely proportional to H square, isn't it? It will be inversely proportional to H square. Right? These are the formula you should memorize for flow between parallel plates, for laminar flow between parallel plates, and both are stationary. The next question. What about the next one? Yeah. Next question. The power consumed means power loss. Power consumed means power loss. That is given by rho into Q into G into HL. And what is HL? HL can be written as delta PL by rho G. So the power loss is equal to Q into delta PL. And what is delta PL? We can use Hagen-Poiseuille equation for laminar flow. The flow is laminar. We can use Hagen-Poiseuille equation. So power loss is equal to Q into, it will be 32 mu V average L by D square. 32 mu V average L by D square. For the same discharge, if discharge is constant, then V is inversely proportional to D square. If discharge is constant, then V is inversely proportional to D square. So power loss is proportional to V average by D square, and V average is inversely proportional to D square. So power loss is inversely proportional to D to the power 4. It will be inversely proportional to D to the power 4. So it is proportional to D to the power minus 4. D is the correct answer. D will be the answer. आप ऐसे भी कर सकते थे इसको, या फिर HL की वैल्यू लिख के भी कर सकते थे. पावर लॉस क्या होगा? रो इंटू क्यू इंटू जी इंटू HL. HL is FL square upon 12.1 D to the power 5. Friction factor, where friction factor is 64 by Reynolds number, or 64 mu upon rho VD. So F is proportional to 1 by VD, and V is inversely proportional to D square because discharge is constant. So F is proportional to D square by D. F is proportional to D. So here power loss is proportional to F upon D to the power 5. If you put the value of F here, then power loss will be proportional to D upon D to the power 5. You will get the same result. Power loss is proportional to D to the power minus 4. Either use Hagen-Poiseuille equation or Darcy-Weisbach equation. That is your choice. The answer will be option D only. D will be the correct answer. Very, very important question. Either numerical is asked or theoretical question is asked from this. The next one, from the turbulent flow. In a fully developed turbulent flow through a rough pipe, it is a rough pipe, the friction factor and the relative roughness, how the Reynolds number, how the friction factor is related. For a smooth pipe, if the pipe is smooth, when the ratio of K by delta dash is less than 0.25, then in that case F is given by 0.316 upon RE to the power 1 by 4. It is a function of Reynolds number only. that is for the smooth pipe. And if the pipe is rough, for a rough pipe, 1 by root f is equal to 2 log r by k plus 1.74. That is when the pipe is rough, when k by delta dash is greater than 6. The pipe is rough. So f is a function of k by d, that is relative roughness. And if the pipe is in transition, then f is a function of Reynolds number as well as k by d ratio. So because it is a rough pipe, it is a function of k by d, that is relative roughness. It is a function of k by d. C will be the answer. It will be a function of relative roughness only for a rough pipe. Getting it? Can you give me the answer for this one? Can you solve this one? Which of them is correct? What you need to understand here is flow always takes place in the direction of decreasing total energy of the fluid. Fluid always takes place in the direction of decreasing total energy of the fluid. At A, energy level is 200. So HA is given as 200. At the junction D, piezometric level, because the velocity at the junction is equal to 0. So the piezometric level, that is HD, is equal to 160. And at B, HB is equal to 180. And at C is equal to 120. So we can find out the direction of the flow. D is having the less energy, so the flow is from A to D. And total energy at B is 180, total energy at D is 160. The flow will be from B to D. And D is having more energy than C. Then the flow will be like this. So it will be Q1 plus Q2 is equal to Q3. Sigma Q at a junction is equal to 0. Or we can say sigma Q in is equal to sigma Q out. So entering will be Q1 plus Q2, leaving will be Q3. So A is the correct answer. It will be A. Q1 plus Q2 is equal to Q3. Q1 plus Q2 will be equal to Q3. The flow always takes place in the direction of decreasing total energy of the fluid, isn't it? ये बता सकते हैं? The next one. If H is the total head at inlet and HL is the head loss due to friction, efficiency of the power transmission. So theoretical power is equal to rho Q into G into H. H is the total energy head. Power loss will be equal to rho into Q into G into HL. So actual power is equal to rho QG H minus HL, theoretical minus loss. So the efficiency of the pipe is equal to P actual by P theoretical. So that is equal to H minus HL by H. That is the efficiency. Efficiency H minus HL by H, option A. That is the answer, efficiency of the power transmission. And if we want the power to be maximum, P actual to be maximum, what will be the condition? HL should be minimum, that should be equal to H by 3. For power transmission to be maximum, the loss should be minimum, that is H by 3. So it should be 1/3 of total head supply, total supply head C, and the efficiency, maximum efficiency will be equal to 2 by 3 or 66.67%. If HL is equal to H by 3, then the efficiency will be maximum, that is 2 by 3 or 66.67. On 1st of November, there is an important workshop conducted by Abhinav Negi sir regarding the blueprint to be the topper in GATE 2025. So you just have to register yourself and attend this workshop at 7:30 p.m. on 1st of November. And day after tomorrow on Sunday, there will be an scholarship test. Do attempt the scholarship test. It is important. Based on your performance in the scholarship test, you can get the discount in various courses. And if you have not downloaded the BYJU'S exam prep app, you download it, then only you will be able to attend the workshop and you will be able to attempt the scholarship test, right? Now, in turbulent flow through rough pipe, the ratio of maximum velocity to the mean velocity, U maximum by V average, 1.43 under root of F plus 1. That is the ratio. It depends on friction factor. The ratio of maximum velocity to mean velocity, U maximum by V average for laminar flow is equal to 2. But for turbulent flow, it depends on friction factor, D. D will be the answer. It depends on friction factor. Now the external flow. Let us move to the external. This is the growth of boundary layer over a flat plate. So initial part of the boundary is laminar. So P is laminar. Up to P there is a laminar. Isn't it? Then Q. Here there will be transition. Q is transition. Then S will be turbulent. S will be turbulent. And R is known as laminar sublayer. R will be laminar sublayer or viscous sublayer. In this region, the flow is still laminar. That is why it is called as laminar sublayer. So P3, 3, 1, 2, 4. 3, 1, 2, 4. 3, 1, 2, 4. A will be the answer, isn't it? A will be the answer. Now, can you solve this one? Can you solve it? What is the answer? The laminar boundary layer thickness in zero pressure gradient. It means, what is the meaning of zero pressure gradient? The plate is kept parallel to the flow. Kept parallel to the flow. That is called as zero pressure gradient. Where is S? So delta X, velocity boundary layer thickness, is given by 4.64 X upon under root of REX. That is the relationship. Or we can write 4.64 X upon under root of rho into U infinity X by viscosity. So delta X is proportional to X by root X. So we can say delta X is directly proportional to X to the power 1 by 2. For laminar, it will be X to the power 1 by 2. Minus थोड़ी होगा. It is option C. तभी तो grow करेगी. Boundary layer will grow. Delta X at any X. X is the distance from the leading edge. It is proportional to root X. For laminar boundary layer. C is the correct answer. The next one, match the following. Boundary layer thickness is delta X, displacement thickness is delta star, momentum thickness is theta, energy thickness is delta E. Boundary layer thickness when Y is equal to delta, Y is become delta X or delta when U becomes 99% of free stream velocity. A1, displacement thickness, integration of 0 to delta 1 minus U by U infinity into dy. Momentum thickness, this is the formula for momentum thickness. And 1, 2, 3, 4, yes Mohit. And there is a parameter called as shape factor. Do you know about that? delta star by theta is called as shape factor, which is greater than 1. So 1, 2, 3, 4. And there is a von Karman equation. Are you guys aware about von Karman momentum equation? According to von Karman equation, tau naught by rho u infinity square is equal to d theta by dx. That is called as von Karman momentum integral equation, where theta is the momentum thickness, x is the distance from the leading edge. This is also valid for laminar as well as turbulent boundary layer. This is also valid for laminar as well as turbulent. Now, if the velocity profile is linear, in a laminar boundary layer, the velocity distribution can be assumed to be given as u by u infinity is equal to y by delta. Which one of the following is correct expression for the displacement thickness? If the velocity profile is given by linear expression, then you should remember delta star is equal to delta by 2, theta is equal to delta by 6, energy thickness is equal to delta by 4, and shape factor delta star by theta, that is equal to 3. Delta star is delta by 2, and if we find out the increasing order, theta is minimum, then delta E, and then delta star, and delta. Theta is minimum, then delta E, then delta star, then delta. Isn't it? The correct sequence, I told you, theta, then delta E, then delta star, then delta. This is the ascending order of the magnitude. Displacement thickness, momentum thickness, energy thickness is not given. What is the correct answer for this one? What will be the answer for this one? Isn't it option C? Moment in the ascending order, increasing order. In the increasing order, isn't it C? Momentum thickness is minimum, then energy thickness, then displacement thickness, and then boundary layer thickness. C is the answer. C होगा ना, ascending order. It is for turbulent boundary layer. Do you know the relation? For turbulent boundary layer, when the Reynolds number is greater than 5 into 10 to the power 5, delta x is equal to 0.316 upon x upon re x to the power 1 by 4. That is the expression. So delta x is directly proportional to x to the power 4 by 5. टर्बुलेंट की बात हो रही है मोहित, x to the power 4 by 5. B, isn't it? B is the answer. The flow separation. What is the condition of separation of the flow? Condition for flow separation: adverse or positive pressure gradient. The flow gets separated in case of adverse pressure gradient. This is how the velocity profile becomes. du by dy at y is equal to 0 tends to 0, and dp by dx is positive. When there is a positive pressure gradient, that is not correct. This is favorable pressure gradient. dp by dx is negative, is favorable. So C and A are not correct. B is the correct answer. B will be the answer, isn't it? Flow separation or boundary layer separation. In case of laminar boundary layer on a flat plate, the local screen friction coefficient is given by, it is a function of x. For laminar boundary layer, it is given by this B, CFX. So we can say CFX is proportional to x to the power minus 1 by 2, or because CFX is equal to tau naught by rho u infinity square by 2. So that is why tau naught is proportional to x to the power minus 1 by 2. And for turbulent boundary layer, CFX is given by 0.059 upon Rex to the power 1 by 5. For turbulent boundary layer, so CFX is proportional to x to the power minus 1 by 5. That is for turbulent boundary layer. Or tau naught is proportional to x to the power minus 1 by 5. So as x increases, the local screen friction coefficient decreases, or we can say tau naught will decrease. Either it is in laminar boundary layer or turbulent boundary layer. As x increases, the friction coefficient decreases and the surface shear stress will also decrease in the direction of the flow. So B is the correct answer for this. Then some questions from the model analysis. Viscous force is related to what is Reynolds number? Reynolds number is ratio of inertia force by viscous force. So viscous force is related with Reynolds number. What is Froude number? Froude number is the ratio of inertia force by gravity force. So gravity represents the Froude number. What is Weber number? It is the ratio of inertia force by surface tension force. And what is the Mach number? That is the ratio of inertia force by elastic force. All the other number will be under root of these numbers. So rho v d by mu is Reynolds number. Froude number is v upon under root of Lg. Weber number is equal to v upon under root sigma upon rho L, and Mach number is v upon under root k by rho. These are elastic forces, isn't it? So 1, 4, then 3, then 2, 1, 4, 3, 2. 1, 4, 3, 2, or 1, 4, 3, 2. D is the answer. D will be the answer. Next is couple of questions from the hydraulic machines. Propeller turbine. In propeller, the flow is axial flow reaction turbine. Propeller, the blades are fixed. A3. France is radial flow, inward radial flow. B1. Kaplan turbine. Kaplan is having adjustable blades. That is why Kaplan turbine is little more efficient than propeller. Pelton wheel is having tangential flow. So it will be 3, 1, 4, 2. 3, 1, 4, 2. D will be the answer, isn't it? Euler equation of turbine giving energy transfer per unit mass, E naught. What is the answer? Energy. Torque is equal to VW1 R1 minus VW2 R2, and power is equal to torque into omega. If we multiply with omega, then omega R1 is U1. So that is equal to VW1 U1 minus VW2 U2. That is the power, that is energy per unit time. That is energy per unit time. VW1 U1 minus VW2 U2. That is Euler equation. This is called as Euler equation. A is the correct answer. In order to have maximum power flow में Pelton wheel, what is power? We want runner power to be maximum. M dot U V1 minus U 1 plus cos beta 2. That is the expression for runner power. So for runner power to be maximum, what should be the condition? U is equal to V1 by 2. The blade velocity should be half of jet velocity. The bucket speed U should be half of jet speed. This B is the answer. And efficiency, what is hydraulic efficiency? That is the ratio of runner power by jet power. The ratio of runner power by jet power. So runner power is m dot into u v1 minus u 1 plus cos beta 2 or cos alpha upon half into m dot into v1 square. So the hydraulic efficiency is equal to 2u v1 minus u 1 plus cos beta 2 upon v1 square. If you put u is equal to v1, so maximum hydraulic efficiency will be equal to 1 plus cos beta 2 by 2. It is greater than 50%. Maximum hydraulic efficiency, it is greater than 50%. 1 plus cos alpha by 2. Alpha is the blade angle at outlet. If alpha is the blade angle at outlet, that we call it as beta 2. So 1 plus cos alpha by 2. A is the answer. What is the expression for specific speed for a turbine? स्पेसिफिक स्पीड कहां ए और डी सेम ऑप्शन है? अच्छा ए और डी सेम ऑप्शन है और बी और सी भी सेम ऑप्शन है. ये ऐसे होना चाहिए था. बी ऑप्शन होना चाहिए 1/2 माइनस कॉस अल्फा और डी ऑप्शन होना चाहिए 1/2 प्लस कॉस अल्फा. ये होना चाहिए. What is the answer for specific speed of a turbine? This is the expression. This is for a pump upon h to the power 3/4. All right. For Buckingham pi theorem, what is the correct answer for this one? The number of independent non-dimensional group, that means pi terms. The number of pi terms. So the relevant parameters are volume flow rate 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 and n is equal to 3. So 8 minus 3 is equal to 5. The number of pi terms will be 5, m minus n. N is MLT, fundamental dimension are MLT. So let us stop here only. If n variables in a physical phenomena contained m fundamental dimension, then the variables can be arranged into dimensional terms n minus m. Right? So that is all from my side for the day. I hope you enjoyed. There are some more questions, but that you can do on your own. So if you want to join our paid courses, one is the crash course running for the GATE 2024 aspirants and another is long term batch is also running for 2025 and 2026 aspirants. All right. So if you are not part of my Telegram channel, I will share the PDF of this session to my Telegram channel. So do not forget to join me on the Telegram. See you in the next such session. Enjoy, take care, have a good night and Shubh Ratri, Sabba Khair, Jai Hind. Thank you very much for joining in.